If you can hear me, please let me know. Then I can start the lecture.
Yes, ma'am.
Okay, thank you. Actually, yesterday we started our course, Fundamentals of Statistics for Technology. Let me share my screen with you. Yes, our first chapter is Descriptive Statistics, and we started our first chapter yesterday. If you can remember what we discussed yesterday, special terms or special terminologies used in statistics. So we went through these basic definitions and concepts. If you can remember, we discussed about population, sample, then census, variables and measurements. I hope now you know the difference between a variable and a measurement, right? And parameter and statistic. Actually, we were discussing last time about parameters and statistics. Today also, I would like to start with these two terms, parameters and statistics, right? So, give me a second. Consider here you have a population, right? I hope you all know the meaning of population in statistics, right? Now, if we have a population and if we cannot examine the data in population, what we are going to do is we are taking a sample from that population. So this small circle represents the sample, right? Sample. Now I told you last time, the measurements that we are going to find from the population are called population parameters. For example, population mean, right? Then population variance. I will tell you about these terms later, right? When we come to the descriptive statistics part, we will discuss this mean, variance, standard deviation, right? For now, please remember there are some terms we find from the population and they are called population parameters, right? So population mean, population variance, or population standard deviation. Likewise, there are some population parameters. Okay. Now, what is the symbol for population mean? The symbol for population mean is mu. That means if you see the symbol mu, you should know the meaning of mu, that is population mean. We use symbol mu for population mean, right? So the symbol for population variance is sigma square, right? Sigma square. Then what is the symbol for standard deviation? Population standard deviation. It is sigma, right? You should know these things. These are called population parameters. Parameters. Right. Now, if we can find these population parameters for a population, right, then actually we are very fortunate if we can find these population parameters. Why we call we are fortunate? Because we do not have to take a sample from this population since we have population data. Since it is it's really difficult for us to take population data or consider population data every time we take random samples from population, right? So if we find same mean, variance, standard deviation for the sample data, right? Sample data, sorry. right? Sample data, like sample mean. Give me a second. It's giving some troubles. Um, I hope now you can see my screen. Right, so if we can find these measures, mean, variance, standard deviation like that, for sample data, right, we call them as, instead of population parameters, we call them as sample statistics, mean, sample mean, right, sample mean. Then sample variance, and sample standard deviation, or sample proportion. So these measures are called actually sample statistics. Sample statistics, right? So sample mean is noted by X bar, right? X bar. Then what is the symbol for sample variance? Yesterday, I told you. Symbol for sample variance is what? S squared. Sample standard deviation, that is S. If we find sample proportion, we use P hat. So if we find the population proportion, we use capital P. Yes, yes. Some of you have given answers. Yes, they are correct. Thank you. Right. So what I need to explain you here, there are some differences between these parameters and statistics. The main difference is we find population parameters for population data, right? And we find these sample statistics for sample data. That's why I told you sample statistics are related to a sample and population parameters are related to population. If we can find these population parameters, population mean, population variance, population standard deviation, then it's okay. So we don't, that means we do not need to have a sample. If we know these population parameters, then we can do the research or we can do the experiment. But most of the cases, it's really difficult for us to find this population parameter with the population size. When the population size is getting a higher value, when it is increasing, so we need to go for a sample, right? Sample. You know the symbol for sample size is simple N. The population size is denoted by capital N, right? So since this capital N is greater than or equal to simple N, we always go for a sample, right? And using these sample statistics, sample mean, sample variance, sample standard deviation, and sample proportions, we are going to find, or in statistics we say we are going to estimate these population parameters using this sample statistics. Okay, so sample statistics, right, are used to estimate population parameters. Understand? Using the sample statistics such as sample mean, sample variance, sample standard deviation, sample proportion, we are going to estimate population parameters such as population mean, population standard deviation, population variance, population proportion. Is that clear? Now, do you know the difference between a parameter and a statistic? Do you know the difference between a parameter and a statistic? Okay. If you do not understand still, please let me know. I will explain it. Okay. If you are not clear, I will use dark colors. Okay. Thank you for reminding me. Black. Can I use black color pencil? Now, is it clear for you? Let's say we have a population. So these are the population parameters that we are going to estimate. Mu, then sigma squared, sigma. Now you know these are population parameters. Okay. Now to estimate these population parameters, right? To estimate these population parameters, we are going to use sample statistics, right? Sample statistics. Now, before coming to sample statistics, tell me what can be the estimator of this population mean? What can be the estimator? Estimator means is a measurement that we use to estimate the particular population parameter. If the population parameter is population mean or mu, the particular estimator would be mu hat. Right? So if the population parameter is sigma squared or population variance, the particular estimator would be sigma squared hat or sigma hat squared. Right? If the population parameter is sigma, then the particular estimator would be sigma hat. Right? So these are called estimators. Estimators. Okay, these estimators are used to find or represent the population, particular population parameters. Okay, right. Now, value of the population mean, we have to use an estimator. That estimator is denoted by mu hat. Okay. Now my question is it same as X bar? What do you think? Yes. Some of you are saying yes. What about others? What do you think? Is that same as X bar? Actually, the answer is it depends on the situation. If we use X bar, right? If we use X bar, this X bar to estimate this population mu, right? This one, if we use this X bar to estimate this mu, right? In that case, this X bar is the mu hat. If we use this X bar to estimate this population mean mu. If we use this population, sample variance to estimate the population variance, this, right? In that case, this S squared is going to be sigma squared hat. Okay, then if we use this sample standard deviation to estimate the population standard deviation sigma, In that case, S is going to be sigma hat. Is that clear? But not every time. This is not valid for every time, because sometimes if we need to calculate mu, right, we use the particular estimator mu hat. Okay, so using mu hat, we are going to predict about the population mean mu. In that case, mu hat can be calculated using in that case, to calculate the value of the estimator mu hat, we have to use sometimes more than one sample statistics. For example, X bar and S. Right? Using these two sample statistics, if we are going to find the estimator of mu, that means mu hat, okay, in that case, mu hat is not equal to X bar or S. It is not equal to X bar or S. It's a function of these two. Okay. Most of the cases, we are going to estimate our population mean mu, this one, right, using both X bar and S. In that case, mu hat is not going to be X bar or S, but it's a function of X bar or S. So some of you are asking me to explain in Sinhala, but now you are in second year. No? I'm not allowed to use Sinhala language, but since this is the second day of the lecture, I will explain it in Sinhala within 1 or 2 minutes, right? So population parameters again, population එකෙන් හොයාගන්න ඕන දේවල් අපි population data ගන්නවා නම් අපිට ආපහු sample ගන්න අවශ්‍ය නැහැ නේ. population data දන්නවනම් population එක collect කරන්න බැරි නිසා තමයි අපි sample එකකට යන්නේ. ඒතර sample එකේ අපිට හොයාගන්න පුළුවන් measurements තියෙනවා mean, variance, standard deviation මෙන්න මේ කියන measurements. එතකොට sample එකේ හොයාගන්න මේ measurements වලට අපි කියන්නේ sample statistics කියලා. අපි ඒකට parameters කියන්නේ. Parameters කියලා කියන්නේ population එකේ තියෙන measurements වලට. Population mean, population variance, population standard deviation අන්න ඒවට. Sample එකේ තියෙන sample statistics වලට තමයි අපි කියන්නේ sample mean, sample variance, sample standard deviation කියලා. මෙන්න මේ sample statistics use කරලා තමයි අපි parameters estimate කරන්න යන්නේ. Right? We use our sample statistics to estimate particular population parameters. Okay? Using the sample statistics, that means using the sample data, we are going to find sample statistics, and using those sample statistics, we are going to estimate the population parameters, such as population mean, population variance, population standard deviation. So if we use an estimator to estimate a population parameters, right, we have to use a symbol for that now. So if we are going to, let's say we are going, sorry, give me a second. Right. Let's say we are going to estimate population mean mu, right? So to estimate this population mean mu, we have to use a population, we have to use an estimator for this mu. So estimator of this parameter would be mu hat. Okay, so using this, the population, using this estimator, we are going to estimate the population mean mu. Okay, are you clear? Now, how can we find this mu hat? Can you see my screen? I think Yes, yes. Now we are going to estimate our mu. Now, instead of this mu, we have to use an estimator for that. Right? Since we do not know the value of mu, we are going to find an estimator for this mu. So estimator is denoted by mu hat. Now, how can we find this mu hat? There are many methods to find this mu hat. I will teach you those methods later. For now, please remember, if we want to estimate this mu hat, right? If you want to estimate this mu using this estimator, we have to calculate sample statistic like X bar, sample mean, and sample variance, sample standard deviation. Okay, so using this sample statistics, we can actually estimate the population mean. Therefore, mu hat is not equal to these three measurements, but it's a function of, it can be a function of these three terms. Okay, I will later teach you how to find these estimators. For now, please remember, for population, we have parameters. It's a numerical measurement that describes the population, and for sample, we have sample statistics, right, which are used to describe the sample statistics. Sometimes we call these statistics as estimators as well. Okay. Right. So I hope now you have a better understanding about parameter and a statistic. Okay. So far, do you have any question? Do you have any question about parameter and statistic? If you do not have any question, I can go forward. So I'm going to define a not a statistic, the term statistics, right? That means the major topic in the course, statistics. So what do you mean by statistics? What do you mean by statistics? It's a collection of method for planning experiments, obtaining data, then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. If I consider the same example, right? Yesterday I discussed with you an example of finding average height of a student in your batch, right? In that experiment, first of all, we need to plan the experiment, right? How do we collect our data? And how do we organize and summarize our data? So you have to plan it first. Understand? So first of all, we need to plan the experiment. Then after planning the experiment, we have to obtain the data. Then what can we do? After obtaining data, we can organize and summarize our data. And in statistics, it's really important for us to present our data in order to general people can understand. They do not know our technical terms, population, parameters, then samples. They do not know those technical terms. So we have to interpret our results in order to understand by the general people, right? So in statistics, basically we have these procedure: planning experiments, obtaining data, organizing the data and summarizing, presenting, analyzing, interpreting, and drawing conclusions. Actually, presenting can be done in two ways: before analyzing data and after analyzing data. Right? After analyzing data, we can present the results. Now, what do you mean by interpreting the results here? Interpreting. Do you have an idea about interpreting results? What do you mean by interpreting? It is same as drawing conclusions, right? After getting the results, we have to interpret our results to the audience. Okay. Okay. Yes, yes. Some of you have given answers for questions. Okay. So now, do you have any questions regarding the definition of statistics? Actually, there are two types of statistics, descriptive statistics and inferential statistics. Descriptive statistics can be done for sample data, right? And inferential statistics can be done for population data. Actually, inferential statistics means drawing conclusions about a population based on the information collected from a sample, right? So statistics can be divided into two parts, descriptive statistics and inferential statistics. So descriptive statistics involves organizing, displaying and describing data. So our first chapter is actually descriptive statistics now. In that chapter, we will organize I will teach you how to organize the data, then display, how to display the data and how to describe the data we collected. Okay, then inferential statistics mean, right, using those sample data like sample mean, sample variance, sample standard deviation, sample proportions. Using those sample statistics, we will estimate our population parameters such as population mean, population variance, population standard deviation, population proportion, right? Those parameters are estimated by using sample statistics. That process is called simply inferential statistics. Inferential statistics, right? So we usually do inferential statistics for population data. So did you understand the difference between descriptive statistics and inferential statistics? Okay, give me a second. I will explain it again. Okay. Let's say we have a population, right? Now we take a random sample from this population of size n, right? And we find sample mean, x bar, sample variance, squared and sample standard deviation S. These terms or these measures can be found from sample data, right? Now, using this sample data, we are going to estimate the population parameters. What are those population parameters? Mu. Now, mu is for population mean. Then sigma squared, population variance. Then sigma, population standard deviation. Okay, so these parameters are estimated using these sample statistics. This process is called inferential statistics. Is that clear? So based on the sample data, we draw conclusions about population parameters. Understand? Now, what do you mean by descriptive statistics? Descriptive statistics. That means describing the sample data or describing the data we collected. It can be either sample data or population data. Anyway, we have to describe the data we collected. Right? So, how can we describe our data? How can we describe our data? Using charts, using tables, right? We can describe our data. The inferential statistics is a branch of statistics that involves drawing conclusions about a population based on information contained in a sample taken from that population. So in inferential statistics, we are trying to draw conclusions about the population based on the sample data. So before doing the inferential statistics, we have to do the descriptive statistics part. Right? So the first thing is descriptive statistics. First, we collect our data, and after collecting the data, we have to organize our data and display and describe the data. After doing this part, we have to go for the inferential statistics part. Understand? The descriptive statistics part is related to sample data, and inferential statistics is related to population data. Is that clear, guys? If you have any question regarding the inferential and descriptive statistics, please ask me now. Did you understand it? Okay. Now let's move on to the next topic, data. What do you know about data? What are the basic types of data? Data. There are two types of data, no? Qualitative and quantitative data. So what do you mean by quantitative data? In the previous example, our variable was height of a student, right? Height of a student. It's a numerical value, no? Height of a student. So quantitative data means numerical measurements that arise from a natural numerical scale. It always has numerical values in quantitative data, right? For example, height, weight, number of children in a family, or number of chairs in the classroom, like that. So such a type of data is called quantitative data. Okay, right. Now, what do you mean by qualitative data? Qualitative data. Qualitative means categorical. We cannot represent our actually we can represent our qualitative data using numerical values, but most of the time when we use qualitative data, there's no any natural numerical scale, but it consists of attributes, labels, or any other non-numerical characteristics. What are the examples for qualitative data? If we collect our data in the previous example, if we collect our data gender-wise, right? Gender-wise, the heights of male students and heights of female students separately, then what is the qualitative data there? Gender. It has only two measurements, no? Male or female. The variable is gender and the measurement is what? Male or female, two measurements. Is it qualitative or quantitative? It's qualitative, right? Yes, choices. If you take your eye color or skin color, it is qualitative. What else? Tell me. Qualitative data. Maybe you need to know the difference between quantitative and qualitative data, right? And it is also known as, the qualitative data is also known as categorical data. They are not numerical, right? Qualitative data is not numerical. Only the quantitative data is numerical. Okay. If we talk about quantitative data further, it can be distinguished between discrete and continuous data. Again, right? Discrete and continuous. Now, tell me, what do you mean by discrete data? Discrete and continuous data. In previous example, we tried to find the average height of a student. No? Now, height of a student, is it continuous or discrete? What do you think? Height of a student? Is it continuous or discrete? What do you think? If there is a discrete data, it's a type of data result when the number of possible values is either a finite number or countable, which means discrete data can be countable or it is finite. It's always finite, discrete data, like 0, 1, 2, 3. If I ask you a question, how many siblings do you have? How many siblings do you have? 1, 2, 3, or 0, right? 0, 1, 2, 3, 4. Likewise, you can have finite number or countable number of possible values for a discrete data or discrete. Can you understand the meaning of discrete? We can always count a discrete variable or discrete data. here I have given you two examples, the number of eggs that hens lay. Actually, we can count the number of eggs that a hen lay, right? We can count them, no? 1 egg, 2 eggs, 3 eggs, 4 eggs, likewise, we can count. That's why we say it's a countable value and it is finite. Okay. Now, what do you mean by continuous? Continuous data. Here I have given you the definition. You can read it. Numerical data result from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruptions, or jumps. So do you understand it? What do you mean by continuous? For example, the previous example, right? We discussed the variable was average height of a student. Height of a student. If we measure their heights in centimeters, right? Centimeters or feet. So we can have values like 150 centimeters, 151 centimeters. Okay, give me a second, I will explain it. So we were talking about continuous data, right? Let's say for experiment, the variable is height, right? Now height can be measured in centimeters. Okay. So there may be values like 150 centimeters, then 155, 157, 158, 160, or we can have values like 151.5, 152.6, or 153.25. Likewise, we can have more values. If you consider these two values, 150 centimeters and 151.5 centimeters. Okay, if you consider these two values, between 150 and 151.5 centimeters, are there any values? Are there any values between these two values? What do you think? Can it have values between these two values, 150 and 151.5? What do you think? Yes, of course. There are uncountable values in between 150 and 151.5. So there can be 150.1 or 150.2 or 150.215. Likewise, there are uncountable values in between these two values. In between these values, 150 to 151.5. Understand? That means if we consider the height of a student is not discrete. If it is a discrete data, we can count it and it is finite value. It's a finite value. But here, this is not finite as well as countable. We cannot count the values in between one interval. If we consider these two values, 150 to 151.5, there are more values which are uncountable and infinite. Therefore, such a data type is called continuous data, continuous values. Understand? So height is a continuous data. If we take weight, is it continuous or discrete? Continuous. Continuous. Then what do you think about your GPA? GPA value. It can be from 0 to 4. Is it continuous or discrete? Continuous or discrete? What do you think? It is continuous. No? Can you understand why it is continuous? Because there are uncountable and infinite values between 0 and 4. We cannot count. Understand? Therefore, GPA can be a continuous value or continuous data. So what are the, okay, I hope you understood the difference between continuous and discrete terms, right? Let us come to our slide presentation, right? So qualitative data and quantitative data. There are two types of data, quantitative and qualitative. And quantitative data can be divided again into two parts, continuous and discrete. Okay. So if it is a discrete data, then we can count it. That means it's a finite or countable number. If it is a continuous data, we cannot count its infinite many values in between a period, okay, or a range. It should not have gaps, interruptions, or jumps. If it is a continuous data, it should not. Give me a second, student.
Recording stopped. Recording in progress.
Sorry for the inconvenience. So we were describing about continuous and discrete data, right? So discrete quantitative data can be divided into two parts as discrete data and continuous data. And then if we move on to the qualitative data, right? What do you think about qualitative data? Can we represent our qualitative data using numerical values? What do you think? In the definition of qualitative data, we didn't. Is here. Qualitative data are measurements for which there is no natural numerical scale, but which consist of attributes like gender, the eye color, skin color. Likewise, there is no natural numerical scale. But my question is, can't we represent our qualitative data using numbers? That means, can't we convert our qualitative data to quantitative data? What do you think? What do you think? Okay, one of you answered. We can convert our qualitative data into quantitative. Yes. What about others? What do you think? Can we convert our qualitative data into quantitative? Yes or no? What do you think? Usually categorical measures or categorical variables are defined in terms of natural, not natural numerical scale, natural language, no, language specifications, no. But in not in terms of numbers, but we can convert our categorical measures into quantitative one, either discrete or continuous. We can actually convert. How can we convert it? That's why I have given you two major parts of qualitative data, nominal and ordinal. Actually, qualitative data further can be divided into two parts, nominal and ordinal. In nominal qualitative data, there is no any natural order between the categories. For example, if you consider the gender of a student or a person, gender cannot be arranged in an order. Gender is just a gender. Can be either male or female. There's no any order between male or female. There's no any middle parts. If you take a person, he or she should be a male one or a female one, right? But if you consider the income level of a person, income level, right? We know income is a numerical value, but income level, using the monthly, by considering the monthly income of a person, we can actually categorize that person into some groups like a rich person or the person who have high level of income, persons who have low level of incomes or middle level of incomes. Likewise, we can categorize them now. That means if we consider their income level, not the income level, there is an order existing between the income level. Can you understand what I'm saying? For example, if we take a person who is earning more than 2 lakhs per month, more than, not 2 lakhs, let's say 5 lakhs per month, he's earning, usually he earns 5 lakhs per month. We can categorize that person into, we can put that person into the category rich people. Rich because he or she earns 5 lakhs per month. If a person earns below 20,000 rupees per month, 20,000. No, not 20,000. Let's say 10,000. Nowadays, we cannot actually survive with those 10,000 rupees per month. No. Therefore, if there's a person who earns less than 10,000 rupees per month, we have to put that person into poor people category. Poor people category. Understand? Now, we mentioned about two categories, rich people and poor people. If a person earns money between 50,000 or more than 10,000 and below 5 lakhs, we can put that person into middle people or people who have middle level of income. Likewise, if we consider their income level, we can actually make an order of their income order using the income level. Understand? So first we examine or we collect the income. Income is a quantitative value. Using the income, right? We define their income level, rich, poor, or middle. Understand? In there, we converted our quantitative data into qualitative. Right? Let's say now we have qualitative data. That means we know whether they are poor people or rich people or middle people. So using that qualitative data, again, we can convert that qualitative data into quantitative data. Understand? So poor people can be defined as the people who earns less than 10,000 rupees per month. Middle people can be defined as the people who earns between 10,000 into 5 lakhs rupees. Likewise, this is just an example, right? In real scenario, it's different, okay? So what you need to understand is qualitative data can be divided into two parts like nominal and ordinal. In nominal data, there's no any natural order between the categories like gender, skin color. Okay, but if you consider ordinal data, ordinal qualitative data, we can actually make an order of those data, of those qualitative data. Here I have given you two examples. One is income level and the second one is exam results. According to your exam results, actually we can make an order. For example, if you take our course, fundamentals of statistics. First, we have examinations, right, to evaluate you. Then we will give you marks for that examination out of 100. Okay, so that score is a quantitative one. Let's say you have scored 85 marks out of 100 for the end. Okay, now 85 marks is a quantitative one. But when we assign a grade for you, right, that 85 marks again converted into a qualitative data like A pass, A plus pass, A minus pass, B plus B or B minus. Likewise, we convert your score into qualitative one. Understand? Now consider your grades. For example, for the first year examinations, let's say you had 10 subjects, 10 courses. For those 10 courses, you had grade like A plus A minus, B plus B, B minus. Likewise, you have 10 different grades. Okay. At the end of the semester, you will know only the grade, no, not the mark for a particular subject, right? So using those grades, again, we are calculating a GPA value for those grades. In that case, your grade will be converted into a quantitative one. Understand? First, we converted your quantitative data, your marks, into qualitative data as your grade. And then your grade will be converted again to a quantitative one as your GPA. Understand? Is that clear, guys? How can we convert our data? Sometimes we can convert qualitative into quantitative and quantitative into qualitative. Understand? There's one more thing to tell you about categorical data. Sometimes categorical data can hold numerical values. No? For example, if I ask you a question, what is your, not age, what's your birth date? Birth date, it's a numerical value. Birth date is a numerical value. But does it give any mathematical sense, the birth date of you? Does it give any mathematical sense? No, it's just a number. It doesn't give any mathematical sense. Therefore, in that case, birth date is a qualitative data, not a quantitative one. Understand? So if I ask you, what is your favorite sport? My favorite sport is carom. What is your favorite sport? It can be either football, netball, cricket, right? So those are qualitative data. Can we order those qualitative data, your sport, your favorite sport? No, we cannot order them. Therefore, it's a nominal data. Okay. If I ask you your gender, it should be either male or female. Now, gender is a qualitative data and it is nominal. It's not ordinal, it's a nominal. Okay. If I ask you your skin color, it's again nominal qualitative data. It's not quantitative. Understand? Anyway, the nominal data helps to label the variables without providing any numerical value. Right? Nominal data usually helps to label the variables without providing the numerical value. But if you consider ordinal data, it can follow a natural order. Ordinal data. Okay. Some of you asked about ordinal data. Again, ordinal and nominal data. Okay, I will explain it again. Qualitative data can be divided into two parts like nominal and ordinal. Okay. Nominal means we cannot make those qualitative data into an order. There's no any order. If you consider your gender has only two measurements. No, it is either male or female. The gender කිව්වොත් එක්ක male එක්ක female. ඒ දෙක අතර කිසිම order එකක් නැහැනේ. There is no any natural order between the male and female. If you consider your favorite color, sometimes your favorite color may be either red, blue, green, black. So is there any natural order between those colors? No, we cannot make any order using the colors. Understand? So such type of data are called nominal data. No any order, nominal data. Understand? But ordinal data means there exists an order between the categories: rich, middle, poor. Or if you consider your age, that is the best example to explain the ordinal data, right? If you consider your age is a number, no? It's a numerical value and it's a quantitative data. But your age can be further categorized to age level. Age level, how? Actually, we can determine using your age whether you are an adult or whether you are a teenager or whether you are a infant or likewise we can actually determine your age level using your age. Understand? So age is a quantitative value, but age level is a qualitative one. Qualitative. Neither. තේරුණාද? පොඩි ළමයිද ලොකු ළමයිද එහෙම නැත්නම් ටීනේජර්ස්ලාද එහෙම නැත්නම් වයසක අයද එහෙම වෙන් කරගන්න පුළුවන් නේද? ඒතර යාලට අපි කියන්නේ ordinal data. There's an order between the categories. තේරුණාද? දැන් අපි ගත්තොත් අපි ගන්නවා sample එකක්. That sample may includes all the the people in all categories, like infants or children, then teenagers, then adults. Okay, adult means who are greater than 18 years. No? Yes, we can consider them as adults. Now I am telling you, if we consider their age level, there is an order between their age level. Understand? Podima infant ni atadaru. It was a children inna. Tikak lokulana. It was a teenagers la inna. Avdu dahatunat dahatat atara. Hari dahatat වැඩි වුණාම adults. ඒතර ඒකේ order එකක් තියෙනවද නැද්ද? ඒකේ order එකක් තියෙනවද නැද්ද? Okay, one of you are asking a question, time. Is it qualitative or ordinal? Good question. What do you think about time? First, we need to understand time is what? It's a numerical one or qualitative one, quantitative one or qualitative one. Time. Actually, time is measured by either seconds, right? Minutes, hours, days, right? Months, years, decades. Likewise, time can be measured in different measurements, different scales. Okay? Therefore, time is a quantitative one or qualitative one. What do you think? It's a quantitative one. Time is the quantitative one. And there's a question whether it is a discrete one or continuous one. Time is a continuous one. It's not the qualitative or ordinal one. It's a continuous quantitative one. Time, variable time. Understand? Okay. So we were discussing about data. Okay, there are two types of data. Mainly we have two types of data, qualitative and quantitative, right? Quantitative data are numerical measurements that arise from a natural numerical scale. That means we always can represent our quantitative data using numbers, right? So it follows a natural numerical scale like weight, height, number of people in a county, or number of students in a class, number of chairs in a class, like that. So qualitative data are measurements for which there is no natural numerical scale, but there's natural language specifications, not numerical scale, but sometimes we can actually represent our qualitative data using numbers. Okay, but usually qualitative data are measurements for which there's no natural numerical scale. It can be either attributes, labels, or non-numerical characteristic like gender. Okay, color, favorite sport, favorite singer. Likewise, we can have so many variables as qualitative variables or qualitative data. Is that clear? Quantitative data can further be distinguished between discrete and continuous. If it is a discrete variable or discrete data, it is a finite, either a finite number or countable. Finite, countable. If it is continuous, it is infinite and uncountable. Understand? If it is discrete, finite and countable. If it is continuous, it is infinitely many possible values between two values. So in a range, there are infinitely many possible values, and it is uncountable. Is that clear? Okay. Qualitative data can be further divided to two parts, nominal and ordinal. In nominal data, there's no natural order between those categories, but ordinal data, there is a natural order between the categories like income level, exam results. For example, if we take two students from your batch, right? Let's say one has got A pass for statistics subject and other one has got A plus pass for that subject, A and A plus. Okay. Is there any order between A and A plus? What do you think? Now A and A plus is a qualitative one. Of course, it's a qualitative one. It doesn't have any numerical value. No. Now my question is, does it have any order between A plus and A? Yes or no? What do you think? Does it has an order? Huh? What do you think? Does it have any order between A plus and A? Of course, they have. Why? You know A plus is greater than A, no? It's a higher score, A plus. Understand, therefore, A plus A minus, B plus B minus, C plus C minus, D plus D, E. That is the order of your exam result or your grades. Understand? Your exam result is a qualitative data, but it is ordinal. There is an order between those grades. But if you consider your gender, male or female, it doesn't have any order. Now, are you clear? Yes or no? Are you clear? Please tell me, guys. Okay,
Yes,
actually in first chapter, right, we have only technical terms right? Special terms used in statistics. So far we discussed about population, sample, census, variable and measurement, then parameters and statistics, and the process of statistics or the definition of statistics. And there are two types of statistics, descriptive and inferential statistics. Then we discussed popular data types, quantitative and qualitative, discrete, continuous, and nominal and ordinal. Okay, so this is the end of the first slide presentation. That means special terms used in statistics. So from next presentation, we will start descriptive statistics part. So our overview of the chapter was basic definitions and concepts, data displays, descriptive statistics. In order to understand this data displays and descriptive statistics, you should know these basic definitions and concepts of these terms. That's why I taught you these terms in the very beginning. Understand? Is that clear, guys? So to understand or to learn about data displays and descriptive statistics, you should know these things. What are the meanings of populations, then samples, parameters, statistics, estimators, data types. Okay. Now tell me, do you have any questions regarding these terms? If you have any question, you can ask me. Okay, I will give you 2-3 minutes. If you have any question, please ask me now.
Recording stopped. Recording in
One
progress.
of you asked a question, Madam, could you please upload the PDF and record lectures? Of course, I will upload all the lecture notes and lecture recordings to the LMS, but still I couldn't create an LMS course. Actually, I have created already an LMS course as CMT 2301. The problem is last batch, they have uploaded their assignments and tutorials to that LMS. No, I have to remove those assignments from the LMS, and then I will let you know the enrollment key. Okay, and also I will create a Google Classroom, right? Through the Google Classroom, it's really easy to communicate. That's why usually I prefer to use Google Classrooms to communicate with you. And I will upload all the lecture notes and lecture recordings to both LMS and the Google Classroom. So if you give me 1 minute, I will give you the passcode for the Google Classroom, right? Can you give me 1 minute? Again, I have a question. Did you see my screen while I'm doing the lecture? Yes or no? Okay. Give me a second. I will create a Google Classroom for you. Okay. Okay, I just created a Google Classroom for this course. Now I'm sharing with you the passcode for that. Okay. Please see your chat. I just shared the passcode for this Google Classroom. You can join the Google Classroom using this passcode. Okay, I will upload all the lecture notes and recordings to the Google Classroom as well. And also I will let you know the LMS enrollment key for this course later. Okay, did you get the passcode, everyone? Did you get it? Okay, using this passcode, you can add to the Google Classroom, but keep in your mind when you log in to the Chrome, you have to use your technology email address. So you all have an email address from our faculty, no? University email address. So you have to use that university email address to log into Chrome if you're adding to the Google Classroom. Okay. Otherwise, you will not be given the permission to add that Google Classroom, because I used my technology email address now. Therefore, you also have to use the same email address. Okay. Mm. Okay, so I'm going to stop the lecture for today because I discussed what I wanted to discuss with you. From next week, we can start the descriptive statistics part, that is popular data displays. That means from next week, we will discuss how to create frequency tables, frequency histograms, relative frequency histograms, and how to create charts. Okay, and then how to find mean, variance, standard deviation for sample data and population data separately. We will discuss those things from next week. So far, we discussed only the special terms used in statistics. Okay, you should know those statistical terms if you are learning statistics. Okay, usually the symbols we learned so far will not change. They give same meaning in throughout the entire course. They give same meaning. So if you see mu, sigma squared, sigma, s squared, x bar, so usually they give those statistical meanings. Okay, so when you come to the next lecture, please go through your previous lecture notes. I will upload these lecture notes and recordings to the Google Classroom and the LMS. Okay. So if you do not have any question regarding today's lecture, I will wind up the lecture for today. Thank you for joining. Thank you very much.